So let's take a look at an example just to continue to practice these examples in the different models. So say we had 4/7 plus 2/3. Again, with the set model, we can use any shapes to show these fractions, but the first step is always to define the whole. And in all cases, we want our whole to be able to show both sevenths and thirds. So we can start with sevenths. In the set model, we then create the set, right? So that way there are 7 objects in it. And so that's what I'm doing here. 1, 2, 3, 4, 5, 6, 7. And so we see this group of 7. Now, if we weren't doing, adding it to the 2/3, we would just show 7 objects. Perfect. 4 of them would be 4/7. But since we want to show both 7s and thirds in one whole, we need to define one set as such. So we can take this row and copy and paste it 3 times. Why would we want to do that? So pause and ask yourself that. Why would we want to take one row of 7 and then copy and paste it so we have 3 of them? How then does this whole right here show sevenths and thirds? And then what is 1/7 and what is 1/3? Right? And I can put a box around it just to show that this is my whole, and then we want to label it as such. So we can, I'm going to call this now not 1/7, but 1. So right here, this set, this 3 by 7 array is now my one whole. And you can put the box around it or you don't have to, whichever makes you feel better. And now let's think about, well, what would be 1/7 if this is my whole? And what would be 1/3 if this is my whole? Well, we got to think about, well, if we are taking this whole and cutting it into 7 equal pieces, right? 1, 2, 3, 4, 5. Oh, sorry, that didn't work. 5, 6, 7. Those 7 equal pieces. So each of those columns then is 1/7. All right, so I'm going to turn off my draw. I'm going to take this 1, 2, 3, right? This column, right, or 3 dots is 1/7. And now what about what is 1/3 then? How do we take this set, right, this one whole, and cut it into 3 equal pieces? Well, if we look across, it has 3 rows, 1, 2, 3 rows. So then that means each row has 7 dots in it and then there's 3 of them, right? So this is an important idea that 1/3, right, has 7 dots in it, and then 1/7 has 3 dots in it. And we're going to see that connection to the Cuisenaire rods when we get to the length model. So now we just take exactly what we have. Now all of the thinking is done for us, right? We're thinking about adding. We just want to take these two fractions and put them together, combine them. So sevenths are, right, our columns. So we have 1, 2, 3, 4. We want to take those 4 columns. Two. Right, so here we want to show 4/7. Maybe I want to move all of this up on my slide so I can put some labels on these at the bottom here. We want to show 4/7 and how many thirds? 2/3. So we want 2 rows. And this is just why I'm using PowerPoint, so I can copy and paste, but you can draw this, you can do this in any way you'd like. And again, when we're talking about adding, we just put them together. So you can put a plus sign there, but you don't even need it. When we're talking about subtracting, we'll talk about take away or comparing. And then, you might want to annotate or add some notations or some captions. I'm going to just make these a little bit smaller. And so I can put them underneath, right? There's my 4/7, and give this lots of space. Oops. There's my 4/7, here's my plus, here's my 2/3, and now I can just count them. And if you think about it, right, if we're talking about equivalent fractions and or common denominators, right, if this is 1/3, this whole piece, then we can talk about 1/3 is the same as 1, 2, 3, 4, 5, 6, 7. 7 out of how many is our whole? Yes, right, is the same as 7, oops. 7/21. And then 1/7 is the same as what? 3 out of, right, the whole, 21. And so this is, again, how we can show this equivalence. And this is why understanding the models and practicing all of that equivalence is really important, because now when we come here, boom, we can just add them together. And here we can see this, and I'm going to actually make this a little bit longer. So now we can put in an equal sign here. So if we look at this as one 4/7 plus 2/3, we can then see 4/7 is the same as 1, 2, 3, 4, 5, 3 by 4, 12, right? 12/21. And again, connect it back to that procedure. 4 times 3 is 12, 7 times 3 is 21. And you could see that, right? When we first took that one row of 7 and then we multiplied it 3 times, right? This is where these concepts come from, or this is how we can show them. And then, so you can think about this as 12/21 plus, well, what's 2/3? Again, we can count them. 2 by 7, it's got to be 14/21. And now you can just add the numbers, or again, count them. We have 12 plus 14, right? We could have counted all of these here. You could, and maybe I'll show that next. We show how we can rearrange these dots, right? These 2/3 to look like 1, and then we know how many we have left over. So 14/21, 21st, right? And now you do 12 plus 14. The way we know how to do add these which is 26/21. So you can leave it right there, right? Don't feel you have to convert it to a mixed number. That's a complete misconception. Leaving fractions in fractional form is really important. So we get comfortable, right? Seeing fractions greater than 1. If we did this, and I'm going to duplicate this slide. So now we see this, but what if, right, here's my 4/7. What if I'm going to take my 2/3 and rearrange it so that way we can find this whole? So 1/7, 2/7, 3/7, 4/7, 5/7, right? I'm making them all those columns. 6/7, oopsie. 7/7 now. Oh, look at that. Here's my 7/7, right? Do we see how this, use red, right? This now I was able to create one whole, right? It's the same as that. And now what do I have left over? 5/21, right? 5 out of this whole. So I want you to practice, create any two fractions, follow these same ideas, right? Create your whole, and once you create your whole that can show both denominators, right? And the set model is great for that, right? The procedures of, oh, find a common denominator by multiplying the denominators. Now you can see where that comes from, right? We want to create this 3 by 7 array because we want this one whole to show both sevenths and thirds, right? It needs to be cut into 7 equal pieces. It needs to be cut into 3 equal pieces. That's the definition of a fraction, these equal partitions, right? The denominator. And so practice, try your own, create your own examples and see if you can do the same thing.